And we are bringing it in. I think this video lecture and one more, we'll complete stars. Remember to review. It's a lot easier to review and a lot more fun. It's like, oh yeah, I'm familiar with that. Oh yeah, I get that. Oh, I can think more deeply. Anyway, the HR diagram, we said last time in that short little video, we want to organize all that information that we've gathered by breaking down the laws of light. So we can look at a group of stars, and there can be a specific group like Pleiades star cluster or whatever, or just in general, what do we expect? So we're going to look at in general, what do we see? For each star, we're going to get and plot two key things, and you know this now. We're going to get the temperature using Wien's law. We get we break it down, get the brightest frequency that star emits, throw it into Wien's law, mathematical equation, get the surface temperature of that star. I mean, it's easier said than done, right? You've got to do this carefully. And then we're going to plot that over there. And then we're going to plot the luminosity, the watts. This, let me emphasize, because people make this mistake all the time. This is not how bright the star is. How bright is a matter of how it looks, and you know the two main factors for that. One is how much light it's giving off, but also the distance. I don't care right now about the distance. I want to know about the star itself. Whether or not I'm close, just want to know about the star. So the fact that it's farther away and making it not look as bright, I don't care. Maybe there's dust in the way too. That's another thing. I'm not going to plot. This is not brightness. Okay. Now you might see a capital M. This is lowercase m, the apparent magnitude, right? First place, second place, 1 being brighter than 2, and so on. 0 being brighter than 1. You might see capital M on some diagrams in textbooks or online, and that's referred to absolute magnitude, and that just ranks the luminosity. And it still does the thing. If it ranks, then 1 is first place more than 2. So as you get smaller and smaller, here you get more luminosity. It's a flip thing. It's confusing, right? First. So anyway, don't worry about it. If you see that, it is a way of relating to the luminosity. But you'll get the idea here, and you'll be good. So how do I get temperature? I use Wien's law. I get the brightest. I need some equipment to get the brightest frequency that it emits. How do I get luminosity? Well, there's a couple ways that we learned. One was I do use how bright it looks and the distance away. For the close stars, I use stellar parallax. Use the inverse square law. I can calculate the luminosity, how much light that star is actually giving off, not what it looks like. In that group of stars, we saw that there were some pulsing stars, and the rate at which it pulsed, the time it took to pulse, was directly tied to luminosity. So if you just got the period of a variable star, you could know the luminosity without knowing the distance. Then you can go back and get the distance. So we can know the luminosity, break it down. We can know the temperature. That's what we did, right? Because temperature and luminosity tells us about the star's mass. You can't see the mass, right? You can't see that mass. You can tell about the stage of life. You can tell about the size. And you can tell about how it's going to end its life, how it will die. None of us know that. So we're going to build this up together, shall we? Let's think about it. You start with two axes. You know what they're going to be. Let's start. I'll just do this. I'm going to start with this one, and I'm going to put them on. Now you could do it however, right? And Hertzsprung and Russell, and you'll see you've already, but this is the idea. This is cool. So on this axis, and I want to make sure I don't skip any ideas here, we're going to plot the luminosity. I'll write it out, even though we could just use the letter L. And I'm going to make a little note here to ourselves. This is not brightness. It's not apparent magnitude, not. Okay, I think I got my point across there. And using what you learned, we might say, well, what's the range? Now you don't have to, I'll give you a sense of that scale, but you don't have to know so much. But remember our 5 foot to 8 foot adult male analogy? I mean, sun's kind of in the middle, not really in the middle. I mean, so I am not gonna be super picky about making this look just, I'll show you exact ones or whatever, but just to give you a sense. Oh, that's cool. Sun is gonna be kind of in the middle on both of these. And so I'm gonna put sun here. It's really a little lower, I don't know, whatever, it doesn't matter. If you want it a little lower, you can make it a little lower, fine. Hopefully you can see that yellow. And this is the luminosity, L, of sun. What's the symbol for sun? Dot, circle, heliocentric, right? That might be hard to see, so I'm gonna box it. So I'm gonna start there. L, luminosity, how many watts of sun? It's gonna go like this, of sun, right? That symbol means sun. So let's make a note. Lumen of sun, helios, Ra, inti, sol, right? Okay, but somewhere in the middle, probably a little lower is better. So now the watts are just crazy. You can look them up, and you'll never remember the number unless you use it for calculations. All right, fine. So then where would I put high luminosity, things giving off a lot of light? Here or here? In this case, your guess would be right. So we've got here, and I'm just going to put this. This is all I need you to know. High luminosity. What does that mean? That means giving off a lot of light. And then I'm going to go down here, and you can guess. I'm just going to go here and put low. Give myself some low. And this is how you would have to do it if you had to draw it on an exam, right? Otherwise, you visualize it, but if you draw it, you can visualize it and answer questions about it. And that means not giving off as much light as what? As sun, or as these guys, so less. Now you might wonder, well, how big a range is there? So I wouldn't ask this myself, but this can go up to about 10 to the 6th. That's 1 with 6 zeros. That's 1,000,000 suns worth of light. We've talked a bit about this. I mean, some of those stars are enormous, and they can give off 1,000,000 times more light. Talk about sunburn. And then down here, this would be nice if it was 1 over 1,000,000. But it's not quite, because as I say, it's not quite in the middle, it's a little lower. Anyway, I'm just gonna write it, you don't have to worry about it, but it's 10 to the -4 suns, about. So somewhere in that range, if you're interested. If, you know, but it's a pretty big range, it's a pretty big range. And you saw that the star size is pretty big. Okay, boom, got that. I got those points on my exam, and I understand it. Now what am I gonna do here? Oh yeah, well, the other thing, what's the other thing? You know. Go ahead and do it. And do it while you're watching. Try to guess. If you dive in and guess and make a mistake, that's how you're going to learn. So here it is. Now this one, I need you to know 3 things. Okay. So here, on this axis, I'm going to do 3 things, and they're all related, which is interesting. 3 related things. Of course, temperature. I don't need specific temperature. You know, it's just a crazy number. You can look it up if you're interested. Yeah, okay, fine. Temp. That's one way. Let's put that up. So for temperature, where would I put high temperature and where would I put low temperature? You're probably wrong. I know I would guess wrong. I mean, usually we make small to large, small to large. This way is flipped. For reasons you can explore if you want, but I'm not going to go into it. So in fact, over here, I'm going to put low T. And over here, I'm going to put, you guessed it, high T. It's the surface temperature of the star. And who do you think's in the middle? Approximately, we don't need to, right? You know, you can look it up if you work it, so someone's going to be in the middle here. T of who? You guessed it, sun. And you might not be able to see that very well, so I'm going to outline that yellow. T of sun. Okay, cool. Got it set up. Not quite. Not quite. What's related to the temperature? Remember Wien's law? Remember that when objects glow, they glow lots of frequencies. Remember when all those frequencies go into our eye, we see a combination of those frequencies, and we might see more of one color than another, and that gives us kind of shades. And remember in chapter 1, we said, oh yeah, if we let our eyes dark adapt and don't look at our cell phone and get out there and no white lights, red lights okay, dark adapt for 15, 20 minutes, then you really start picking up some color, especially if you're away from city lights and everything. You start picking up some shades of color. Good old chapter 1. And oh, surprisingly, I used color over here, didn't I? So let's put down this, let me write colors. I don't know, I'll use black for colors. But let's just say color shades. Whatever. Remember those 4 shades? So color shades. Shades of color. And so what you start seeing is sort of a red. And you could say red-orange, but I'm going to say orange-red because as I get hotter, you start seeing higher frequencies. Orange. Orange-red. I got room. I can make that bigger. Let's make this nice, huh? Can make that bigger. Red. Not very dark, is it? Orange. Or orange, red, orange, however you want to say it. What's next? You bet. Good old sun, right? That's sun. So yellow, giving off a lot of green light, but it's not a green star because we have to see the combination and our eyes are sensitive to different ones, etc. And what do I get over here? Remember that? Oh yeah, 5 foot, 6 foot, 7 foot, 8 foot. Oh, these were white, weren't they? Ugh. That E's hard. Those are white stars. And what do you have over here? Oh, yeah, I remember this now. Blue, white. White, all the colors. Here, all the colors, but a lot of blue because high frequency. Why is that? Oh, they're high temperature. High temperature is high frequency oscillation. Low temperature is lower oscillation. Lower oscillation creating lower frequency light. Lower vibrating atoms creating lower frequency light. Higher frequency vibration, higher temperature atoms, higher frequency light. You've got that now. You're sick of me saying it. Oh, shoot. There's one more, isn't there? Remember Annie? Annie cannon, Annie jump cannon. Now, why does this matter? Because people use it. And if you ever read anything about astronomy, when people refer to stars, you can tell a lot about a star. And so I ask it on my exams, my final exams certainly, the spectral class. We refer to them by their spectral class. Right? And their spectral class, do you remember that? What was Annie's memory aid? It was O, B, A, O like OH, B, BE, A, fine. Let me do it, emphasize the white of it. A, fine, and Again, the lines blur, that's fine. Girl, or you can use guy. Hopefully you can see that, but I'm gonna make that as a G, right? That'll be a fine girl or guy. Kiss. Me. And then I added the extra memory aid. Just kind of added onto that. Interesting. My refillable pens needs to be refilled. All right. Well, that's not bad. All right. What was that? Well, that was like OB. If you just remember that, you've got it, but you got to know which ones start. So this is ouch, burn. I just kind of add that in there. And then this one is cool with a K, man. All right, cool man. OBA fine girl or guy. Kiss me. Okay, cool. So, man. Ouch, burn. Got this. All right. So I've got some points. All right, cool. I even know where sun is. Hey, wait a minute. I'm not showing the picture of Orion and Taurus and all that stuff. I'm just plotting the characteristics of the star. And I know the first star I can put because I already know the luminosity. And I know the temperature. So here it is, and I might as well use the symbol for sun, right? Right there. Let me see if you can see that. Let's label that sun. Go ahead and do that on your page. Yeah, you kind of see that, right? You kind of see that. All right, sun. Suna, Sona. Sol, Inti, Ra. Helios. Sun. Who knew? Who knew that the other stars were the same sorts of things? There's a range. Well, Giordano Bruno thought it was. Check out, I put in some quotes and some things from him in the book. Right, he thought that the other stars were suns and there could be worlds. And how glorious would that be? None of this says anything about God, but he thought, being in the church, that would be glorious. But if you're using the front of pretending to know everything from God, anyway, it's a problem, right? But now we know. We know these things. So don't make things up and manipulate people. Okay, that's that. Now, I've got a question for you. What about the other stars? This is huge. Think it through. Pause. Think hard. Think hard. Connect it, because that thinking is going to connect all these different factors. If something is a low temperature star, will it have a low, medium, or high luminosity? In general, what would you expect? If something is a high temperature star, would it have a low, medium, or high luminosity? If it's a high temperature star, would it give off not so much light, a lot of light, a lot of light? What makes sense? What happens as something gets hotter? Does it glow more? Yes. Things jiggle more. They glow more. And so doesn't it make sense? Of course it does. To say that a star, any one of those stars that has a low temperature is going to have a low luminosity. And maybe if it's a little hotter, it might have a little higher luminosity. And a little hotter, a little higher, and some variation, right? A little hotter, a little higher, meaning giving off more light, right? A little hotter, giving off more light, more luminosity. I don't know where the red stops. I'm not taking this too literally, right? And then a little hotter. Oh, changing color, isn't it? More luminosity. Maybe a couple up here, something like that. Interesting. Does that make sense? If it gets hotter, it's going to glow more, glow more, glow more, glow more. If it gets hotter, it's going to glow more. And as it gets hotter, it glows more. It gives off more. Not brightness, how much light it's actually giving off. What would make it hotter and so glow more? That's the other question, right? You can write these questions down. Here's let me put these questions on the side, then I'll get rid of them actually. So the question is, does lower temperature, I'm not sure you can see that, let me make sure, does lower, you can see it, does lower temperature give low luminosity, medium luminosity, or high, wait, that's not how you spell high, luminosity? We answered that question. That makes sense, right? So make sure you write that down. I'm going to erase it here in a second. The next question, why would a star be hotter? Got this? Pause. Think. Review. If you even review, take the time and you save the time. And the reason is you pause? You can pause. I'm not going to wait for you. You can pause and come back. More mass gives more gravity. You remember this. Which gives faster fusion, which gives more light, right? More mass gives more gravity, faster fusion, not burning, giving more light. And so, yeah, it makes sense. Why is it hotter? Because, these have less mass. These have more mass. 5 foot, 6 foot, 7 foot, 8 foot. Not a bad analogy. Here we go. Let's do this. This is going to tell us so much. Here we go. In fact, we can do this. Let's do it. This group here, and I'm just not going to, you can get into hyper detail and all, but those are the low mass stars. And let's write that, okay? So low mass, and sun is included, but low mass stars. And what do you know about low mass stars? You know, come on. That's going to be most stars, right? Most people are less than 6 feet, or 6 feet and under, right? That's most stars. And they fuse slower, so live much longer. keep repeating the same idea, and it's new to you, but now it's getting less new, and so it'll be easier to hold on to. What do I have next? You betcha. The old 6 foot to 7 footers, right? We call that the high mass stars. And what do you know about high mass stars? Well, there's fewer of them, right? There's fewer 6 to 7 foot people. And you know they fuse faster. And that means they've got shorter lives. Have I got room? I think I've got room. Okay. And then up here, well, what have you got here? Kind of like to keep that over there if you don't mind. Okay. Can put it over here. I guess I'll keep it over here. Very high mass stars. Even fewer, even faster fusion, shorter lives, even shorter lives, much shorter, much shorter. Look it up, check it out. It's a lot, right? I throw all these numbers at you. So you go about your plotting and you find out that this is true. You find a star, Betelgeuse, Rigel, whatever, put it in here. Wait a minute, you do Betelgeuse and you go, wait a minute. Something's wrong with Betelgeuse. Even to my eye, I can tell it's a reddish orange, something in there. And you find out it is, it's over here. But it looks really bright. But that could be because it's close. This isn't how it looks. So you gotta do the stuff and you go, well, actually it's giving off a lot of light. Crazy, look it up. Look up the luminosity of Betelgeuse. But it doesn't make sense. What are you gonna do? Remember when you're walking in a crowd, you see the tall ones, even though most people are down here, you see the real tall ones, right? The ones that are really extraordinary. But this one's a low temperature, so Betelgeuse is somewhere in here. And there are other ones. We see the high luminosity stars, right? That usually means they're 7 to 8 foot, 6 to 7 foot, you know, that analogy. High luminosity stars. And we'll see these guys too. So we see this group. Not the patterns, but the temperature and the luminosity. And that whole group in here is funny. Why? Because they're low temperature, and we call them red. We usually just call them red. But they're high luminosity. How could that be? How could that be? Well, if I have one glowing red thing, and then I increase the amount of glowing red surface, you're going to get more light, more surface because it's larger. In fact, it's going to be huge. In fact, we call that a red giant. These are the red giants. And you go, well, that doesn't make sense. I know, we'll talk about it. I mean, it's not hot. I mean, it shouldn't be giving off much light. But we said why? Oh, because it's big. Well, what makes them so special? Why is it so big? Maybe it's just big. Let's talk about that. And then you keep looking and plotting stuff, And you find some down here. Now what is this? You find some that are really hot, but they're not giving off much light. Right? What's up with this? So they're hot here, they're hot. So we're going to call them white. But they're low luminosity, so they must be small. If you take a needle, a pen, and make it really white hot, it's still not going to light up your room because it doesn't have much surface. So if they're small and yet white hot, it's still not going to give off overall, and we're going to call that a white dwarf. And I'll just say it so you remember when I say it again. These aren't stars anymore, but they're often called. Okay? So that's, in general, what we find. Now, you could also add this group. Ones that are hot and high luminosity, but kind of in here. We call these super giants. You can get into more detail. Okay, so in there. So that gives you a sense. That's what you find. That's the HR diagram. And you thought somewhat about that, but you, as any discovery, any good discovery is, you are led to new questions. So let's how are we doing? We're doing well. We've got that. I've made all those points, and I've got that. I made those points. Yeah. Well, let me make this point. In terms of life, how long does the sun live? Total life? Around 10 billion years total life. Right? So much longer lives, much shorter lives. Again, I'll leave that to you if you want to find out. And that's kind of good news for life, biological life. So let me, there's your HR diagram. Now, I'm going to draw some conclusions. We're almost done with this video. And let's do this, and let's show you a few pictures here, just really quickly. You can just do a search, right? HR diagram, and you'll see a variety of things. So let's come over here, and then I'm going to draw a quick conclusion, which will lead us into our last stuff. So you can see these pictures, and if you look over there, you can see the luminosity going from 10 to the 6 to 10 negative 4. I'm psyched about that. That's good. I like that. And they do have the little symbol for sun in there, but not very much. So sun, you see, is a little bit lower than the middle, but that's okay. Temperature, they got color, but I don't really like the green in there. It's kind of a, whatever, white dwarfs, giants. You probably should call those red giants, but whatever. It's got a little curve to it. Okay, fine. Oh, wait. Look at that. It says a main sequence, that line. Let's check this out again. Now, I expect you to be able to draw like this. Of course not. That's ridiculous. Okay, it's beautiful, nicely done. But anyway, there are all these different stars, and you can name them, and you can plot them on there. And you got a sense of that, so it doesn't have to be perfect. You can plot them. All right, so temperature versus luminosity. Oh, be a fine girl. Okay. All right, cool. So, wait, that line is called the main sequence. Could it be? Could it be? Yes. This is where we're going to conclude our HR diagram exploration. And then I could, you ask different questions about this to help you get acquainted, right? This is getting lower temperature, this is getting higher temperature. Changing the temperature changes the overall sort of combined color, right? And we look for the brightest frequency. This is how much light is given off, more and more light given off. Why? Well, because more mass, we said, more gravity, faster fusion makes it hotter, more mass. All right, cool. So this line is called the main sequence. Where should I put it? Well, that line all up in there, that's the main sequence. And we talked about what the main sequence was. And I'm going to put that over here in conclusion. And then we're going to talk about how stars become red giants, white dwarfs, how stars go through life cycles, and how they die in the last video lecture. And I hope, this is, the intention is to stimulate further thought, if so interested, and if not, to certainly to understand this much. Looking up in the night sky, you can make up patterns, make up stories all you want, but this is what's up. Big old nuclear fusion factory, balls of gas. We are surrounded by enormously hot balls of gas. And those are only the ones close to us in our galaxy that we see, right, with our naked eye, but telescopes can go way past that. Okay, so here's what I want to say. Yeah, I kind of do it like doing it that way. Yeah, all right, cool. Main sequence, stars. I kind of like this. I don't know if it's useful. Wait, let me see. Most stars are main sequence and make sense. How do they make sense? Well, we said the hotter temperature a star, the more luminosity. But it's not always true, right? But it's true for main sequence because these make sense, right? And main sequence stars are this. It's the first stage, quick review of life, the first fusion cycle. You know what's happening. Quick review, beat me to it. We're fusing 1 hydrogen to 4 helium, releasing light. No, that's wrong. You didn't nod your head, did you? No, you're tired. So, is that, what should I have written? Yeah, that's right. This is 1. You need 4 of these to make 1 of those. So let's get that right. And it's a sequence anyway. And that gives a light. Where's that happen? In the core. Is the core solid? Iron? No, it's all gas. All gas. Right? That's what's happening. And it keeps doing this. For most of the star's life. Keeps doing it for most of the star's life until death. Until death do us part. But after that sequence is done, there's more sequences, and there's another video. We're going to talk about that, and we're going to talk about how this really, really gets the point across. Keep it simple without getting too technical, unless you want to get into it. And yeah, that's the main sequence. See if you can draw it, see what kind of details you can put in there, then peek back and then try it again, peek back, try it again. That's how you do it. If you think about it, it makes sense. We're just charting this. So we've got star life cycles or fusion cycles going to star death. Ciao.